Hi everyone, let's take a look at representing systems and energy changes on worksheet 6. There'll be 3 things that you'll need to do for each problem. The first is drawing a system schema where you're going to indicate what objects are in your system, what's your focus, and what's interacting. Then you'll draw energy pies at the minimum for the initial and final states of your system. It says to draw or to write a verbal description. I meant by that a written description. And then finally, construct energy bar charts or LOL charts. Make sure you list out the things that are in your system or that are in your focus in the O part of the LOL diagram down on the bottom. All right, let's get started. This example says a student lifts some books from the bottom of his locker. So right away, let's list out books. Earth, remember these are just the objects that are interacting. Student and locker. You could add air in there if you'd like to. Remember to show interactions using double-sided arrows. The earth is going to be interacting with everything. The student interacts with the books. I'm going to say the student doesn't actually touch or interact. Oh, they will, because they're going to have to open their locker and close the door. And for sure, the books are in the locker. And this time I'm only going to focus on or only include in my system the books and earth. And mainly because I want to show when I do my LOL diagram that the student adds energy to my system, which is just now I've decided just to be the books and the earth. And that also allows me to leave out ECH for energy that the student has, although I could have had the student in my system. So I know that I'm going to put books and earth in my system. For my energy pies, I'm going to say that the books in bottom of locker. And then over on the right, I'm going to say books being lifted. So they're actually moving upward. Okay? And then I think it's helpful to kind of list out in my mind what kinds of energy are in the system initially, and then at the end, and then I decide how big my pie slices should be. So if the books are in the bottom of the locker and I am only focusing on the books and the earth, gosh, they're not off the ground. Or maybe I could say that they're a little ways off the ground, since the locker usually has a shelf or a base at the bottom. And nothing's moving. So I'm going to say maybe a little bit of EG, and then the rest I'm going to say is internal. So I'm going to put a little slice of EG. I could even make that a smaller slice. And then the rest is internal. And then for the books being lifted, and I'm only focusing on the books and the earth, I'm going to need more EG because they're going to be up higher. So maybe I'll go, let's go a quarter. That way I can for sure see that that's bigger. Could go more than that. They're being lifted or they're moving, so that's going to be EK. And nothing's heating up. Nothing's changing state of matter. Nothing's being stretched or compressed. So maybe I'll just split the rest in half and say this is my EK, and then the rest can be internal. And right along with that, since I kind of want the LOL chart to be similar, I'm going to say that my first block of energy is EG, and then the rest I'm going to make internal. Let's go 4 blocks. And this time with my LOL chart, I can be a little more specific. Energy to lift those books has to come from somewhere. Where does it come from? It's coming from the student that's lifting them up. You can make it however many boxes that you want of working energy. So let's say, I'm just going to list it out. From student. And remember, the law of conservation of energy says you can't create or destroy energy. So if I have 5 boxes to begin with and I gain 2 more, then over here I'm going to need 7 boxes. All right, let's get started. Just looking at my pie that I did first. So I'm going to need EG, and that's going to increase. Let's say maybe 2 boxes worth. And I need 7 total, so that's 2 of my 7. Then if I need, actually, yeah, let's go 2. So I need 5 more boxes total. Let's put 3 in EK. And let's put the rest internal so it goes right with my pie. And not exactly, because I do have, well, I guess it is close. I have EK that has equal amount of EINT. Oh, wait, I can't count. That's 8 boxes. Let's actually delete a little bit of the EINT because I have to have it add up to 7. So my bars don't completely agree with my pies, but that's okay. What's most important is that I have 7 boxes of energy. Energy wasn't lost or created from anywhere. I can account for all of the boxes of energy. And I hope that was helpful.